So now we need to actually come up with a formula that will calculate the derivative of a function. And hopefully you took a look at that Desmos activity. That's going to kind of help us with this. I want to analytically calculate the derivative at x, the slope of a line tangent to this function, f, at x. And again, if that's too hard for right now, what I'm going to do instead is I'm going to put another point on here. And instead of doing my tangent line, I'm going to do my secant line. I'm going to draw in this secant line like that, which is actually not a bad approximation for the tangent line there, but I can get better than that. And I've got some other point over here. I am going to say that that other point is h units away from my point over here, that's x, which means the x-coordinate of this point is going to be x plus h. By the way, the coordinates of this point, x comma something. Actually, the something shouldn't be a big deal. X comma, plug into your function f, I'm going to say x comma f of x. The other point, x plus h, comma, well, just f of x plus h. I want to go find the slope of that secant line, first of all. The slope of my secant line is going to be, well, rise over run, or really probably y2 minus y1 over x2 minus x1. I'm going to get f of x plus h minus f of x over x plus h minus x. I can do a little bit of simplifying in the denominator. I'm going to get f of x plus h minus f of x over, okay, you know what, x plus h minus x. I can cancel those x's, and my denominator is just going to be h. And that's the slope of my secant line. If we want to get the slope of a tangent line, and hopefully this is what you saw in that Desmos activity, rather than going all the way from x to x plus h, I can make this distance shorter. I can move this point closer to this one, and closer and closer and closer. And really, what do I want the distance between those 2 points to get really close to? Well, I want that distance to get really close to 0. What can I use to say, let's make that distance get really, really close to 0? Hopefully you said limits. The slope of my tangent line, or my derivative, f prime of x, is going to equal the limit. As h approaches 0, as the distance between those 2 points is approaching 0, really the horizontal distance, I guess, of f of x plus h minus f of x over h. This is my formal definition of the derivative. What this is going to end up giving us, and we'll look at some examples in just a moment, this will create a formula that will find the slope at any particular x value. Let's see how to use this. First example. We are going to calculate f prime of x, the derivative of f of x, for the function f of x equals x squared minus 3x plus 2. When we're done, we're going to find f prime of 3. So I want to first find f prime of x, a formula that would let me find the slope of this parabola anywhere. Specifically, I do want to focus on x equals 3. I want to find the slope of that parabola when x equals 3. First thing I'm going to do, f prime of x equals, I'm actually just going to go and recopy that formula. I'm going to say this is the limit as h approaches 0 of f of x plus h minus f of x over h. And then I need to go try to find f of x plus h, f of x, and all those things. This is going to be the limit as h approaches 0 of f of x plus h means I'm going to go plug x plus h into my f function where the x is over here. So that's going to give me x plus h in parentheses squared minus 3 times in parentheses x plus h plus 2. That's f of x plus h. Minus f of x, well, f of x is just this thing over here. X squared minus 3x plus 2 all over h. This f of x plus h, that's this piece. The f of x, that's this piece. And we're going to subtract them. Well, now we have a bit of algebra to do. Take a moment, go through the algebra. The video is going to stop, not really asking you any questions, but just stop. Go through the algebra and resume the video when you're ready to pick up. Okay, this is the limit as h approaches 0 of, I'm going to go and write out x plus h twice so I can do some FOILing. I really, really hope you didn't just distribute the square. I need to actually distribute and all that stuff. Then I'll distribute the minus 3 and get minus 3x minus 3h plus 2. Distribute the negative minus x squared plus 3x minus 2. All over h. Okay, this is the limit as h approaches 0 of x squared plus xh plus another xh, I'll combine those in a moment, plus h squared. I'll just recopy the rest, minus 3x minus 3h plus 2 minus x squared plus 3x minus 2 all over h. Then we can combine like terms up top. We're going to get, let's see, the x's cancel. Those I can combine into 2xh. The 3x's cancel. The 2's cancel. I'm going to get an h squared minus 3h over h. This actually should look fairly familiar from some of the limit problems that we dealt with in the beginning of Unit 1. They were just sort of limit problems there. They didn't have any meaning. Now we're seeing that that particular type of limit question will find the slope of a curve. Well, simplify this thing, because if you plug in 0 at this point, you're going to get 0 over 0. You know what? Take a moment. Either separate your fraction or factor an h out of the top and cancel, and see if you can finish this problem off. I'm going to get the limits as h approaches 0 of, I guess I'll factor this time, h times 2x plus h minus 3 over h. This is going to equal the limit as h approaches 0 of 2x plus h minus 3. I'm going to plug in 0 where the h is. I'm going to get 2x plus 0 minus 3, and I'm done. F prime of x is 2x minus 3. What I have just created is a formula that will find the derivative, that will find the slope of this parabola at any x value. Now, this particular problem said to find f prime of 3. Well, I'm going to go and I'm going to plug 3 into that formula. F prime of 3 equals 2 times 3 minus 3. Okay, that's 6 minus 3. That's going to give me 3. The slope of that parabola at x equals 3 is 3. How about we take a look at this and see what's actually going on? If I went and I graphed that parabola, x squared minus 3x plus 2, plus 2. Let's see, at x equals 3, 1, 2, 3. Is the slope over there 3? It seems like it could be reasonable. It's positive slope. It's a steeper than like 1 positive slope. Yeah, I think that kind of worked.